Have you ever watched a drone flying in the air, hovering calmly, then suddenly moving forward, turning, going up, going down, and stopping perfectly in one spot without falling? In many people's minds, drones feel like magic. They have propellers, a camera, and somehow they can fly with incredible precision. Some people wonder, is the drone fully controlled by a human, or does it actually fly by itself with humans only giving commands? Others are curious how a drone can stay stable, even though the propellers are small and the wind can come from any direction. Questions like these are very normal, because drones are a technology that looks simple on the outside, but is extremely complex on the inside. This video is made for you who really want to understand how drones work, not just knowing, but truly understanding the full process from start to finish. We will break down drones not with stiff technical language, but with stories, analogies, and real examples from everyday life. Imagine we are sitting back watching a light documentary that slowly reveals the secret of how a small machine can fight gravity. By the end of this video, you will not only know how drones can fly, but also why modern drones feel so smart, and what common mistakes people often make when flying them. Let us start with the most basic question: what is a drone, and where did this technology come from? Because to understand how drones work, we need to go back to a time when humans were just starting to dream about flying machines without a pilot inside. A drone is basically an unmanned aircraft that is controlled remotely or flies semi-automatically. The word drone comes from English and refers to a male bee because of the buzzing sound it makes when flying. At the beginning, drones were not created for hobbies or cinematic videos like we see today. In the 1940s, drones were used by the military as training targets and for high-risk surveillance missions. The goal was simple: to reduce the risk of losing pilot lives. Over time, sensor technology, small computers, and batteries developed very fast. In the early 2000s, drones started leaving the military world and entering civilian use. At first, they were expensive, complicated, and only used by professionals. But when smartphones evolved, everything changed. Small sensors, gyroscopes, accelerometers, and smart chips became cheap and easy to produce. Modern drones are basically a mix of aircraft technology, smartphone technology, and embedded computer systems. That is why today's drones can stay stable without professional pilot skills. They do not just fly, they think. Drones read their environment, correct their position, and adjust propeller speed hundreds of times every second. If you imagine a drone as just a flying toy that is not fully accurate, a drone is more like a flying computer that happens to have propellers. And to understand how it works, we need to go into the core principle of flight and how propellers fight gravity. In the next part, we will talk about how a drone lifts off the ground in a way that looks simple but is full of calculation. The basic principle of flight: why propellers can lift a drone. The main reason a drone can fly is lift force. Drone propellers spin very fast, pushing air downward. When air is pushed down, a reaction force pushes upward, lifting the drone. This is the same principle used by helicopters. The difference is, most drones have 4 propellers or more. The most common drone is called a quadcopter because it has 4 propellers. 2 propellers spin clockwise and the other 2 spin counterclockwise. Why different directions? Because if all propellers spin in the same direction, the drone would spin wildly. With opposite directions, the rotational forces balance each other. Now imagine you are holding a bucket of water and spinning it. If the spin is unbalanced, the bucket pulls your hand. The same thing happens to a drone. Every small change in one propeller's speed affects the drone's direction. If the front propellers spin faster, the drone tilts backward. If the left side spins faster, the drone moves to the right. All drone movements forward, backward, turning, going up, going down, are controlled only by changing propeller speeds. There is no steering wheel, no wings, just rotation speed. This is what makes drones look simple but very sensitive. A tiny change can make the drone lose balance. And this is where the drone's brain becomes extremely important. Without automatic control systems flying, a drone manually would be almost impossible because humans cannot correct mistakes hundreds of times per second. In the next part, we will enter the drone's brain that makes all of this possible. The drone's brain sensors and automatic control. Every modern drone has a flight controller. This is a small circuit board that works like a brain. Inside it, there are key sensors called a gyroscope and an accelerometer. The gyroscope reads tilt and rotation. The accelerometer reads movement and acceleration. Together, they tell the drone if it is tilted, moving, or being shaken. The drone reads this data hundreds or even thousands of times every second. If the drone tilts left, the brain immediately commands the right propellers to spin faster. All of this happens without you noticing. That is why a drone can hover steadily, even when the wind blows. Modern drones also have a barometer to read altitude. GPS to know position, a digital compass for direction. All these sensors work together like a small team constantly communicating. When you release the control sticks, the drone does not fall. It returns to a stable position because of its automatic system. If we use an analogy, a drone is like a bicycle that balances itself. You only decide where it should go. Without this system, a drone would be just spinning propellers. This is where simple AI starts to play a role. Not movie-style AI, but control algorithms that are extremely precise. The more expensive the drone, the better these algorithms usually are. In the next part, we will see how humans communicate with drones through remotes and signals. Remote control signals and communication. When you hold a drone remote, you are not directly controlling the propellers, you are only sending commands. These commands are sent using radio waves. The drone receives the signal and its brain interprets the command. For example, when you push the stick forward, the remote sends a signal that means move forward. The flight controller then calculates which propellers need to spin faster and by how much. This communication happens continuously. If the signal is lost, the drone usually enters fail-safe mode. Some drones will land automatically, others will return to their takeoff point. This is the return to home feature. Besides, control signals are also used to send live video to your screen. The drone's camera streams video data in real time. That is why distance and signal interference strongly affect flight quality. In areas with many signals, a drone can lose connection. This is why drone flying rules are very important, not just for legal reasons, but also for safety. In the final part, we will talk about common mistakes and the right mindset when understanding drones. Common mistakes and the right mindset. The most common mistake is treating a drone like a toy. In reality, a drone is a flying machine. The second mistake is ignoring the environment. Wind, terrain, and signal strength greatly affect flight. The third mistake is ignoring the battery. Drones depend heavily on power. When battery levels drop, propeller strength weakens. Many drone crashes happen not because of damage, but because the battery runs out. The right mindset is seeing a drone as a system, not a single part, but a combination of technologies. When you understand the full flow, you do not just fly a drone. You respect how amazing this technology really is. A drone is not just a tool, but a small window into how future technology will move forward. And all of this starts with small propellers fighting gravity. If you like content like this, click the subscribe button and like to support this channel, and share it with a friend who needs insights like this. Power system batteries and why flight time is limited. Now let us talk about something that silently controls how long a drone can stay in the air. Power. Every drone depends heavily on its battery. Most modern drones use lithium polymer batteries. These batteries are light, can release power very quickly, and are perfect for flight. But they also have limits. A drone does not slowly lose power like a flashlight. Instead, when the battery drops, performance can fall fast. This is why drones feel strong in the first few minutes, then suddenly feel weaker. Every motor, every sensor, every calculation needs electricity. When you push the drone harder, flying fast, fighting strong wind, or carrying extra weight, the battery drains much faster. This is also why flight time written on the box is often longer than real-world flight time. Those numbers are measured in perfect conditions: no wind, slow movement, and gentle hovering. In real life, wind is never perfectly calm. The drone constantly fights small air movements. That means motors work harder and power drains faster. Smart drones monitor battery health every second. When the battery reaches a critical level, the drone will warn you or automatically return home. This is not to annoy you, but to protect the drone. Because when power is gone, there is no backup. Gravity always wins. Understanding batteries is not just about flight time, it is about safety. Many accidents happen because pilots push their drones a little too far, distance too strong wind, or ignoring warnings. The drone does exactly what physics allows, nothing more. In the next part, we will talk about how drones see the world and avoid obstacles. Vision systems, cameras, and obstacle avoidance. At first glance, a drone camera looks like it is only for video, but in modern drones, the camera is more than that. It is part of how the drone understands the environment. Many drones have multiple cameras: front, back, bottom, and sometimes sides. These cameras work together with sensors to detect distance, movement, and obstacles. When a drone moves forward, the front sensors scan the space. If an object appears too close, the system reacts. Some drones slow down, some stop completely, some fly around the obstacle. This is not magic. It is real-time calculation. The drone compares images frame by frame, looking for changes, patterns, and depth. This process happens many times per second. This is why obstacle avoidance works well in daylight, but can struggle in low light because cameras need visual information. Without enough light, the drone becomes less confident. This is also why thin objects like wires or branches can be hard to detect. They do not reflect much light and are visually complex. Understanding this helps pilots trust the system, but not rely on it blindly. The drone assists you, but does not replace awareness. The camera system also helps with stability. Bottom cameras help the drone know if it is drifting, even without GPS. This is why indoor flight is possible with some drones. They use visual positioning instead of satellites. In the next part, we will look at how software updates and algorithms shape drone behavior. Software algorithms and why drones get better over time. One interesting thing about drones is that they can improve without changing hardware. This happens through software. Inside every drone are control algorithms. These algorithms decide how fast motors spin, how sensitive controls feel, and how stable the drone reacts. When manufacturers release updates, they often improve these calculations. Better stability, smoother braking, more accurate hovering. The drone you fly today can behave better than the same drone last year, even though the motors and propellers are exactly the same. This is why updates matter. They are not just features, but flight behavior improvements. However, software also follows limits. It cannot break physics. A small drone cannot fight a storm. No update can change that. Understanding this builds a healthy mindset. Drones are smart, but not invincible. They rely on code sensors and energy. When all three work together, the experience feels magical. When one fails, reality shows up fast. That is why professional pilots respect limits. They fly with margins. They plan battery usage, check weather, and understand their equipment. In the final part, let us tie everything together and see the big picture. The big picture. Why drones matter. When you step back and look at a drone, it is not just a flying camera. It is a combination of physics, electronics, software, and human input. Propellers fight gravity sensors, read reality algorithms, make decisions. Batteries power everything, and humans give direction. When all parts work together, flight feels effortless. This same technology is used beyond hobbies: search and rescue, mapping, agriculture, inspection, delivery experiments. Drones are not toys and not magic. They are a glimpse of how machines and humans will collaborate in the future. Understanding how drones work is not just about flying. It is about understanding modern technology itself, small systems working together to solve complex problems, and it all starts with simple ideas. Push air down, go up, correct mistakes fast, respect limits. If you like content like this, click the subscribe button and like to support this channel, and share it with a friend who needs insights like this.